All right, now we're going to move on to what are called rational inequalities. And for a rational inequality, we're going to have a set of steps again. It's going to be very similar to the polynomial inequalities with one exception. So first thing we want to make sure for rational inequalities that you're dealing with a rational expression, and then the inequality means that you're going to have a symbol other than equals. Now the first step is to isolate the rational expression on one side of the equation, just on one side of the inequality, just like we did with the polynomial inequalities. Then we'll replace the inequality sign with an equal sign and solve. Now we did that also with polynomial inequalities. Then we will find, this is an additional step here, we need to find where the original rational expression is undefined. So we're going to have to figure out what numbers are not allowed to be plugged in. Then on number 4, we plot both of the answers from 2 and 3 on a number line, and we pick our test points and then plug them into the original inequality. Then part 5, from that we will determine all of our solution intervals, and remember that we will never include the numbers from part 3 where our rational inequality was undefined in our final answer. So let's take a look at an example. And I'm going to start out with a real basic example here. Let's try and solve x over x minus 7 greater than or equal to 0. Okay, so step 1 is to isolate. Now we've already got this rational expression on one side and then the 0 on the other side. So we've got step 1. Step 2, we replace this inequality sign with an equal sign, and we solve the remaining the remaining equation. Now, because we have a fraction on the left side, what we can do is we can multiply both sides of the equation by the least common denominator, which is x minus 7. So I multiply the left by x minus 7, I multiply the right by x minus 7, and what's going to happen is that we're going to get the x minus 7's to cancel. We'll get x equals, and then 0 times anything is 0. So we have one solution so far, x is equal to 0. Now we move on to step 3. Step 3 says to figure out where your rational expression is undefined. So I go back to the original one here, and I look at this, and I look at the denominator, and I need to say to myself, remember, x minus 7 cannot be equal to 0. If it's 0, then we have division by 0. So x cannot be equal to 7. If it's 7, then we're going to have it's going to be undefined. So the number 7 and the number 0 are going to be our important points. So what we need to do now is go to our number line. So I'm going to draw a number line over here. I'm going to put our two solutions, 0 and, even though we don't want 7, I'm going to put it here. And then from there we break up our number line into now 3 regions. We need to pick a test point here, here, and here. So I'll pick -1, I'll pick, let's say, 2, and something over here like 8. And what I'm going to do is with these test points, I'm going to plug them into the original inequality and see what happens. So when I plug -1 into here, I get -1 over -1 minus 7 greater than or equal to 0. Now the numerator is -1, the denominator is -8 greater than or equal to 0. Well, a negative divided by a negative is positive, so that's 1/8 greater than or equal to 0. And this is true. 1/8 is bigger than or equal to 0. So that means I can include this entire region over here. I'm going to do the same thing for the number 2 now. So I go in, I plug it in. So 2 over 2 minus 7, that's 2 over -5 greater than or equal to 0. 2 over -5 is a negative number, and therefore it cannot be bigger than 0. Therefore I can say that the middle region here is not included in my solution. Then I go to 8 and I check again. So I'm going to plug 8 in here, 8 over 8 minus 7, that's 8 over 1, and of course that's just 8. 8 is bigger than or equal to 0, so I do want to include those points. So we've got our regions. The main thing now is to determine what we're going to do at 0 and at 7. So let's think about this. Can I include 0? Well, if I include 0, it makes our expression equal 0. And because it says greater than or equal to 0, we are allowed to include that point. So again, it's because of this equal sign that we do include this point and everything to the left of it. Now on the 7, remember, 7 was the one number we are not allowed to put in here. So we're going to have to leave an open circle here, and then everything to the right of that is good. So now let me write our answer in interval notation. That was step 4 here. Let's see, we've got everything to the left of -1, that's negative infinity to -1. We do want to include -1. Unioned with everything from 7 to infinity. We do not want 7, so we're going to put a parenthesis around 7. So that's the solution set for that rational inequality.